everyone. It's really great to be here and introduce you guys some of the background knowledge regarding the workshop. So we named this workshop as Morphing Plant Prosthetics. The goal for this workshop will mainly be design devices for plants, and those devices will either help plants to respond to environmental challenges or enhance the interaction between humans, animals, and plants. And the in-class session will mainly focus on brainstorming and sketching, and we also encourage all of you to design and fabricate your device after class. So let's first talk about why plants. Interaction with plants has been known for therapeutic for human beings. Especially under a pandemic setting, people have found stronger inherent eagerness to have more contact with nature. Meanwhile, most of us don't really know that much about plants. Humans and plants live on different time scales, and we have different sensing capabilities, and we communicate in entirely different ways. It even takes experts years to understand plants before they fully know what their biomarkers mean. Plants can have as many as 15 different kinds of sensings, way more than human beings. They are extremely sensitive to the environment. The sensing happens rapidly within the plants. However, the changes are usually inconspicuous to humans due to the fact that the plants express them really slow. Technologically enhanced human-plant interactions have been explored recently. Some examples: Botanicus interacticus, done by Disney Research, uses swept frequency capacitive sensing technology to turn plants into remote control. Cyborg botany, done by MIT, grows conductive wires within plants and then connects them to external hardwares, making plants motion sensors. Telegarden is a community garden that allows users to plant and tend seeds in a remote garden by controlling a robotic arm through a web-based interface. And Project Florence, on the other hand, uses natural language processing technology to assist conversation between humans and plants. So today, for our workshop, let's imagine a technologically augmented garden that is smart enough to tell you facts about your backyard that are otherwise hidden or unknown. And your job today would be designing the smart devices that can be situated outdoor and attached to your favorite plants in the backyard. And the device will be fabricated using pneumatically actuated flat materials, which you've learned in previous lab sessions that by lookup. And here's some early examples. By playing with different patterns with plastic film, the artificial leaf displays a human-level agency. The gestures of the artificial leaf could be more easily related to by humans. For example, in the left one, it's easier to imagine like the leaf saying somehow hi to you, while on the right-hand side, it seems like it's trying to tell you to leave it alone and no touching. So before physical prototyping, we want to start this with brainstorm session first in class. In the session, we will be using this classic sentence to help us structure the design scenarios. And here's the base loop that is fundamental when generating stories and something that you will be referring to repeatedly in today's workshop. You might have seen this before, and the key components here are who, situation, mismatch, trigger, action, and impact. And we have listed out some options for each section. Under the who section, you can choose among humans or animals or plants as the subjects of your scenarios. For the situation, we have suggested some that are either human-related, animal-related, or plant-related, and you're more than welcome to come up with your own. And after you have decided those two components, you can now discuss the mismatch condition you've observed given who and the situation. Here's one example. For who, we picked grandma in this case, and for situation, we chose education. And the mismatch/problem condition here would be something like, my grandma wants to plant her favorite osmanthus flowers in her garden, and she wants to learn if the soil condition is appropriate, but she does not have that immediate knowledge. Another mismatch example would be something like, the roses in my backyard needs caring while I'm away for a 1 month long summer vacation, but no one will be around. And in this case, we chose plant as the subject and the automated gardening as the situation. So after defining the problem, now it is time to come up with some solutions. For the solution part, we would want you to consider triggers, actions, and impacts. Here we define triggers as inputs that will directly lead to the change of actions of the device. So some of the triggers could be from the environment, such as warming temperature, pH imbalance, nutrient deficiency, etc. Triggers from human behaviors or human gestures, motions could be touch, talk, smell, etc. And triggers from animals could be something like foraging or laying eggs on the plants. And you can do a little bit of research to come up with your own triggers. And after the triggers, it will be the action part. And this is the core of your final prototyping. We invite you to consider three things. Who is the hosting plant? And here on the slide, we have listed some locally grown and pollinator-friendly plant species. And of course, you can choose something that you're more familiar with. And we want you to consider what kind of gesture or motion your device will exhibit. This will be directly associated with the impact of your device in the end, whether it is attracting or repelling animals, or is it displaying information for human beings, etc. And in order to achieve that impact, what kind of motions your device should be taking on. Last but not least, which organ do you want your device to be attached to? This is also worth thinking because it will affect how you want to design the functional connection between your device and the plant. So some of the organs include root, stems, leaf, flowers, fruit, etc. Yeah, so we realized that this is a relatively complicated loop under a given scheme. We have established a sample loop for your reference. So you can see on the slide, in the loop, the subject is monarch butterfly and the situation is extinction. The triggers are toxins and foraging. The hosting plant is butterfly milkweed. The motion of the output device is opening up and closing. And the organ I would like to attach this device to would be leaf. To construct the sentence, it would be for monarch butterfly who is on the verge of extinction, the device on the milkweed will open up and release repelling scent given it detects pesticides in the plant when monarch butterfly is approaching. And from there, you can infer, okay, the impact of this design or this device would be saving monarch butterflies by preventing them from being poisoned. And based on that loop, you can come up with some simple sketches as shown on the slide to describe the scenario, in a very quick way. I hope those introduction helps, and you can feel free to ask questions if you have any. During the brainstorm session, you can refer back to the slides to take a look at all the triggers or other factors we have listed on the slide, and you can find them on the lecture slide.